Hi all, myself ELSA PAUL, Assistant Professor, Department of Civil Engineering, Rajagiri School of Engineering and Technology. Today, let us discuss on the provision for ductile detailing of RC structural members as per IS 13920-2016. This is one of the topics in the structural dynamics and earthquake resistant design, which is one of the electives for S8 civil engineering students. First, let us discuss the ductile detailing for beams. As per IS 13920-2016 Clause 6, this ductile detailing can only be applied if the factored compressive stress is less than 0.08 FCK. Also, width to depth ratio of the beam should be greater than 0.3. The width should not be less than 200 mm and the beam depth capital D should not be greater than 1/4 of the clear span. Regarding the width of the beam BW shall not exceed the width of the supporting member plus distance on either side of the supporting member. This is the width of the beam BW. This shall not exceed the width of the supporting member. This is the width of the supporting member plus distance on either side of the supporting member. Distance on either side of the supporting member is the smaller of C2, which is again the width of the beam, width of the supporting member, or 0.75 C1, where C1 is the breadth of the supporting member. Regarding the longitudinal reinforcement to be provided for the beam, at least two numbers 12 mm dia bars should be given at the top face and bottom face. Rho minimum, which is the minimum longitudinal steel ratio, is equal to 0.24 root FCK divided by Fi, and rho maximum is equal to 0.025. At the face of the column, longitudinal steel on the bottom face should be at least half of the steel on the top face. At the face of the column, that is the beam framing into the column at these junctions, longitudinal steel on the bottom face shall be at least half of the steel on its top face at the same junction. About the anchorage length from the inner face of the column should be equal to the development length of the bar in tension plus 10 times the diameter of the bar minus allowance for 90-degree bend. This is the anchorage length from the inner face of the column. Criteria for lap splices is given in IS 13920-2016 Clause 6.2.6. If the longitudinal bars are lapped, closed links should be provided in that region. Spacing of these links should not be greater than 150 mm. That is, the spacing of these links at the lap region should not be greater than 150 mm. Then the lap length of the reinforcement bar should be greater than the development length of the largest longitudinal reinforcement bar in tension. Also, the lap splicer should not be provided within a joint, within this beam column joint like this. Lap splicer should not be provided in that region. Also within a distance of 2D from the face of the column. This is the distance 2D, where this is the effective depth of the beam. Lap splicer should not be provided at this region, that is 2D from the face of the column, also from the inner face of this inside column. Then within lap splices should not be provided again within the quarter length of the beam adjoining the location of flexural yielding, that is at a distance of L/4 from this face of column. Next is the transverse reinforcement. Criteria for transverse reinforcement is given in IS 13920-2016 Clause 6.3. Minimum diameter of this link is 8 mm. Only vertical links are provided in beams. In normal case, link is made of a single bend bar. If two bars are used, U-link with 135-degree hook with an extension of 6 times the diameter is used. Also, this extension should not be less than 65 mm. As per clause 6.3.3, shear force capacity of the beam should not be less than factored shear force as per linear structural analysis and factored gravity shear force plus equilibrium shear force when plastic hinges are formed at the ends of the beam. For beams with a right sway, VUA is equal to VUA of D plus L minus 1.4 into MU AS plus MUBH divided by LAB. Similarly, VUB is equal to VUB into D plus L plus 1.4 MUAS plus MUBH divided by LAB, where LAB is the clear span of the beam. Then VUA of D plus L and VUB of D plus L are the factored shear force at ends A and B due to vertical loads acting on the span. Then MUAS and MUAH are the sagging and hogging moments on the beam, and MUBH and MUBS are the hogging and sagging moments at B. This is the equation for sway towards left. Spacing of the links over a length 2D from the face of the column shall be of the minimum of these three, that is D by 4, where D is the effective depth of the beam, or 8 times the diameter of the smallest longitudinal bar, or 100 mm. This is the reinforcement detailing for a beam. First link should be given within a distance of 50 mm from the face of the column. For a distance of 2D from the face of the column, closely spaced links should be given. This is applicable for the interior columns and for the exterior columns. Then the remaining portion, in this remaining portion, the spacing of the links should not exceed D by 2, where D is the effective depth of the column. This is the reinforcement detailing of beams as per IS 13920-2016. Next is the ductile detailing for columns. As per IS 13920-2016 clause 7, this ductile detailing can only be applied if the factored compressive stress is greater than 0.08 FCK. The minimum dimension of the column shall not be less than 20 times dB, where dB is the diameter of the largest longitudinal reinforcement bar in the beam which passes into the column. Also, the dimension of the column shall not be less than 300 mm. Aspect ratio, that is, the ratio of the smaller dimension to larger dimension of the column, shall not be less than 0.45. Minimum number of bars required for the circular column is 6, and for rectangular columns it is 4. For the lap spliced region, the spacing of the links should not be greater than 100 mm. Also, the lap length should not be less than the development length of the largest longitudinal reinforcement bar. Lap splices should be provided at the center half of the clear column. Lap splices should be provided at the center half of the clear column, that is at a distance of L by 4 from the face, from both the faces. Not more than 50% of area of steel bars shall be spliced at any one section. If the diameter of the bar is greater than 32 mm, lap splices cannot be applied. Then we have to adopt mechanical splices. Lap splices should not be provided within this joint or within a distance of 2D from the face of the column. Usually transverse reinforcement are provided in closed loops. Spiral or circular links and rectangular links can be used as transverse reinforcement. Spiral links are used for circular column and rectangular links are used for rectangular columns. Closed link with 135-degree hook with an extension of 6 times the diameter can be used as transverse reinforcement. Also, this extension should not be less than 65 mm. Then for rectangular links, if the diameter of the longitudinal bars is less than 32 mm, minimum 8 mm dia bars must be used for rectangular links. If the longitudinal bars diameter is greater than 32 mm, we have to use 10 mm dia bars. Maximum spacing of these rectangular links should not be greater than 300 mm. If the when the length of one side is greater than 300 mm, cross ties should be provided. As per IS 13920-2016 clause 7.5, the shear force capacity of the column should not be less than these two, that is the factored shear force as per the linear structure analysis and the factored equilibrium shear force when plastic hinges are formed at both ends of the beam. If the sway is towards right, VU is equal to 1.4 MUAS plus MUBH divided by HST. For if the sway is towards left, VU is equal to 1.4 MUAH plus MUBH divided by HST, where HST is the story height. MUAS and MUAH are the sagging and hogging moments at A, and MUBH and MUBS are the hogging and sagging moments at B. Next is the special confining reinforcement. Special confining reinforcement criteria is given in IS 13920-2016 clause 8. Special confining reinforcement should be provided for a length of L0 from the face of the joint towards the midspan of the beam and towards the mid height of the column. This L0 should not be less than the largest lateral dimension of the member or 1/6 of the clear span or 450 mm. Then this is the distance L0 from both the faces. Then spacing at that region, that is spacing for L0 region, should not be less than 1/4 of the should not be greater than 1/4 of the minimum member dimension or 6 times the diameter of the smallest longitudinal bar or 100 mm. For circular links, the minimum area of cross section required is the maximum of these two, that is the maximum of 0.09 SV dk FCK divided by Fy into Ag by Ak minus 1 or 0.024 SV dk FCK by Fy, where SV is the pitch of spiral or spacing of the links. The dk is the diameter of core of circular column measured to outside of the spiral link. Then FCK is the characteristic compressive strength of concrete. Fy is the 0.2% proof strength of transverse steel reinforcement. Ag is the gross area of column section. Ak is the area of concrete core of column section, which is equal to pi/4 dk square. Then regarding the area of cross section of the rectangular links, area of cross section should be maximum of these two, that is 0.18 SVH into FCK Fy into Ag by Ak minus 1 or 0.05 SVH FCK by Fy, where H is the longer dimension of the rectangular link and Ak is the area of confined concrete core in the rectangular link. So this is the ductile detailing for the column as per IS 13920-2016. So in this lecture we discussed about the RC ductile detailing for beams and columns as per IS 13920-2016. Thank you.